Hey, wanna know where we live? Well, here's our home address. No one. The Sun, 4.37 million miles away. Surrounding it are 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, and Pluto. Some of those planets have their own moons. Altogether, there are 219 known moons in this solar system. It's just us and our home address that makes up the solar system. But what is out there beyond that? Let's fly through space to find out. First stop, Alpha Centauri. The star system next door to ours is called Alpha Centauri. It's only 4.37 light-years away. That means if you took a rocket ship going about 186,000 miles per second, it would take you just over 4 years to get there. But before you can take off, you'll have to pack your bags, because there are 3 stars in the Alpha Centauri system, and they all very different from our Sun. Proxima Centauri is a red dwarf. It's smaller and cooler than our yellow dwarf Sun, Alpha Centauri. A is very similar in size and temperature to our Sun, but it's 11 times brighter. And finally, there's Alpha Centauri B, another yellow dwarf like our Sun, but 16% bigger and 14% more massive. All these stars are orbited by planetary systems, but we don't know too much about them yet. Scientists think that one of the systems may have an Earth-like planet around it, but so far no one knows for sure. Next stop, New Star Factory. If you keep flying past the planetary systems of Alpha Centauri, you'll end up at a place called the Beehive Cluster. This cluster contains hundreds of hot young stars surrounded by clouds of dust and gas. It's one of the closest star clusters to us. The cluster is 600 light-years away, which means it would take a spaceship traveling at the speed of light over 600 years to get there. At that distance, it looks like just one star. When viewed from Earth, you can see a bunch of bright stars in the sky, but those are all very far away. The brightest is Proxima Centauri, followed by Alpha Centauri A, and then Alpha Centauri B. Next stop, the Cat's Eye. As you continue your journey into deep space, you'll come across a gorgeous blue-green glowing cloud of gas and dust. This is the emission nebula known as the Cat's Eye. It's 3,300 light-years away and is 33 light-years across. The nebula gets its lovely color from the hot gas emitted from the young stars within the nebula. Some of the stars are still forming and are cocooned off in little bubbles of gas. These bubbles act as stellar nurseries, where new stars can be born. Each star within the Cat's Eye has its own planetary system, and we may even discover an Earth-like planet within one of them. But first, you'll have to pass through the ozone layer of the nebula. It's not as protective as the one surrounding Earth. There aren't any cute birds trying to get through it, but it does block some harmful ultraviolet radiation from getting to us. Next stop, the Southern Cross. Continuing our journey, we arrive at a group of stars known as the Southern Cross. The stars that make up the cross are between 6,000 and 17,000 light-years from Earth. The Southern Cross is actually a constellation of stars, a group of stars that appear close together in the night sky. The stars aren't actually close together, but they look that way from where we're standing on Earth. There are other constellations too, such as Orion the Hunter, the Big Dog constellation, and of course, the Big Dipper. Every culture has its own constellations, stories, and myths explaining their origins. In Native American cultures, the Big Dipper is known as the Seven Sisters. According to tradition, they tell the story of 7 sisters who fled their brother who wanted to marry one of them. They were turned into birds by a magical pipe, and each sister became a star. Different cultures have different stories, but the shapes in the sky remain the same, unchanging and eternal. Next stop, the Orion Arm. Now we're approaching the Orion Arm, also called the Local Spur. This is a spiral arm of the Milky Way galaxy. We're in the middle of a flat pancake of stars that's about 100,000 light-years in diameter. The Orion Arm is only about 2,600 light-years thick, but it's 10,000 light-years long. It stretches from the Sagittarius Arm to the Perseus Arm. The Sun is located in the Orion Arm, about 2/3 of the way out from the center of the galaxy. Most of the action in the galaxy happens in the arms. Stars and dust are created in the spiral arms. They're drawn toward the center of the galaxy by its gravity, then thrown back out again. They form new stars and eventually die. They form new stars and eventually die. Over billions of years, the cycle continues. Next stop, the galactic center. Traveling further still, we reach the heart of the Milky Way. Here you'll find the supermassive black hole known as Sagittarius A star. It weighs 4 million times more than our Sun. There isn't anything else quite like it in the galaxy. The supermassive black hole is surrounded by several smaller black holes. These were probably once neutron stars. Neutron stars are the collapsed cores of massive stars that exploded as supernovas. There are also many blue and red giants here. Red giants are big, cool stars near the end of their lives, and blue giants are big, hot stars in the middle of their lives. There are also lots of open star clusters. These are groups of young stars that formed from the same giant cloud of gas and dust. The galactic center is the birthplace of our galaxy. Stars formed here 13.6 billion years ago. Since then, they've been pulled by gravity into a flat pancake. Eventually, the Sun and the other stars will move to the center. However, it will take hundreds of billions of years for that to happen. Next stop, the Great Rift. Leaving the center of the galaxy, we encounter a huge dark patch of dust and gas stretching over 300,000 light years. This is the Great Rift Valley. Stars are born in the dense molecular clouds that stretch across the valley. However, many of the stars have been blown away by the expanding shell of gas and dust from a supernova explosion. This explosion was one of the most violent events in the history of the universe. The star that exploded was almost 20 times the size of our Sun. Next stop, the Magellanic Clouds. The two small galaxies near the Milky Way are called the Large and Small Magellanic Clouds. These galaxies are irregular in shape. Unlike the spiral shape of the Milky Way, they're too small to have spiral arms. Instead, they look a bit like a couple of pieces of chewed bubblegum squished onto the sky. They orbit the Milky Way every 200 to 300 million years. These galaxies are relatively close to the Milky Way, only 163,000 light-years away. They're actually satellites of the Milky Way, meaning they orbit it just like our moon orbits Earth. Next stop, the halo. Now we're at the edge of the Milky Way. Beyond the stars of the galaxy, there's a giant spherical cloud of gas, dust and dark matter, Vs. This is the halo EV. The halo extends 100,000 light-years from the center of the galaxy. It surrounds the disk of the Milky Way like a giant bubble. Many globular clusters are found in the halo. These are tightly packed groups of stars held together by gravity. Globular clusters contain some of the oldest stars in the universe. Next stop, nothing. For hundreds of billions of light-years, there's nothing. We don't know what's out there because we haven't discovered it yet. We can't see very far. Our telescopes can only see objects that are relatively close to us. Everything else is too far away to be seen with the naked eye or with our current technology. The only thing we know for sure is that the observable universe is infinite. No matter how far we go, we won't find the edge. And even if we did, there would be more beyond that. So where do we live? We live in the Milky Way galaxy, one of billions in the observable universe. Our solar system is just a tiny part of the galaxy. We don't know what's out there in the rest of the universe, but we're searching for answers. Maybe one day we'll find another Earth or maybe even another us. But until then, we'll continue to explore the unknown and push the boundaries of human knowledge.